This episode is proudly sponsored by HASA, the trusted choice for liquid chlorine. It's better because it offers the highest purity, works instantly, and contains no added CYA. By the bottom feeder, professional-grade battery-powered swimming pool vacuum system, it sucks to clean pools, so cleaning pools sucks less. Get $100 off the bottom feeder with code DVB100. Skimmer, trusted by over 30,000 pool service professionals across North America. Skimmer software helps you save time, grow revenue, and boost your 5-star reviews. Whether you're just starting out or expanding your team, Skimmer's easy-to-use tools and expert support have you covered. Upgrade your business in 2025 with Skimmer. Try Skimmer for 30 days for free at getskimmer.com/poolguy.
The Pool Guy Podcast Show. The Pool Guy Podcast Show. The Pool Guy Podcast Show.
Hi, welcome to the Best of the Pool Guy podcast show. In this episode, I'm going to sit down with Bob Lowry. We're going to talk through some common chemistry myths that you may have heard out there. So we're going to unpack several of these. And this is part one of a two-part series where we're going to unpack a lot of myths that have been propagated out there in the industry. Join my coaching program and take your pool service to the next level. Connect with other pool pros in your area, gain valuable knowledge, and transform your business with personalized one-on-one advice from me. With over 36 years of experience, I'm here to help you succeed like never before. Learn more at poolguycoaching.com. Let's jump to the common chemical myths that you hear out there. The first one that you hear, some of the common chemical myths that you hear out there, one of these is trichlor tablets don't add a lot of cyanuric acid in my pool because I get a lot of evaporation in my area. We'll just take California as an example. In my area, I would say I'm losing about an inch, maybe an inch and a half a week when it's, during the summer. And so people will say, well, since I'm adding fresh water to the pool, the trichlor tablets aren't adding as much cyanuric acid as they normally would be if it wasn't evaporating. I hear that a lot. And what do you say to that myth?
Well, the myth is that you think that cyanuric acid evaporates, and it doesn't. The process of evaporation is like the process of distilling. Only pure water evaporates out of the pool. All of the calcium, all of the TDS, all of the chlorine, all the stuff that's in the water stays there, and the pure water evaporates. Everything else stays behind. So as you add cyanuric acid from the tablets, it builds up. And as you use chlorine, the chlorine becomes chloride in the water, which is salt and part of TDS. So all of it eventually becomes a solid in the water that can or can't be a problem. But cyanuric acid builds up. And as I've said in another podcast, the amount of cyanuric acid is for each 10 parts per million of chlorine added by trichlor, you get 6 parts per million of cyanuric acid. And if you're using 10 parts per million of chlorine a week, your cyanuric acid is going up by 6 parts per million per week, or 25 per month. Or if you've got a swimming season that's 5 or 6 months long, you're looking at the cyanuric acid going up 100 to 150 parts per million in one swimming season.
Yeah, which is a lot.
It's huge.
So the only way it comes out of the water is with, backwashing, partial draining, maybe splash out from a lot of pool use.
Yeah, it's only from water loss. Mm-hmm. Whether you intentionally drain it, bathe or drag out, splash out, or a leak. But in any case, it's because you've lost water, but not because of evaporation.
This makes total sense. And I think people have that. I don't know where this comes from, but I hear it a lot. So this one, thanks for clearing that up. And then, of course, if you don't want to use trichlor, you're going to switch to an alternate chlorine type. We've talked about this before, that all chlorine has a byproduct. And I've heard this a lot too. I don't really want to go to liquid chlorine because that will add too much salt to my pool and raise the TDS level too high. And what do you say to that when someone says that to you?
You're right. Every chlorine has some byproduct or something that it's combined with that gets into the water. And with trichlor and dichlor, we get cyanuric acid. With liquid chlorine, we get salt and sodium and chloride. With calcium, we get calcium and chloride. So we end up getting something in the water. In the case of liquid chlorine, we get about 30 parts per million of salt into the water for each gallon that we put in the pool. If it's a 10,000 gallon pool and a 15,000 gallon pool, then you're looking at about 22 parts per million for each gallon. So it's only going to increase TDS by 22 parts per million per gallon. How many gallons are you going to put in that pool? And if you're putting in a gallon a week, even your TDS is going up by 20 parts per million a week. And at the end of a whole year, you're looking at it going up 50 times that. It go up by 1,000 maybe. But in the scheme of things, increasing TDS by 1,000 ppm means that for the saturation index, it takes 1,500 parts per million to change the saturation index by 0.1. So it's not, in a year, it's not doing hardly anything. And don't forget that other kinds of chlorine, they all add something. And so even when you add trichlor and dichlor, all of that is eventually being dissolved in the pool. When you put a pound of dichlor in the pool, it all becomes TDS eventually. Sure, some of it is chlorine right now, but when the chlorine is not chlorine or not HOCl, it goes to being chloride in the water. So all of the chlorine, no matter how you put it in the water, all of it ends up being part of TDS.
Yeah, and I think every manufacturer kind of throws the other chlorine type under the bus, so to speak. And so the fact that liquid chlorine adds salt to the pool, I've heard from I'm not going to name the manufacturer, but this is one of the things they promote in their literature, that, hey, you're adding a lot of salt to your pool, you're raising your TDS, and that's why you should use our chlorine type.
And so you've got cyanuric acid buildup with dichlor and trichlor. You've got salt buildup or TDS buildup from liquid chlorine. If you use cal-hypo, you got calcium buildup. And just like we talked about the cyanuric acid buildup, the calcium buildup from using cal-hypo is for each 10 parts per million of chlorine added by cal-hypo. If it is 65% cal-hypo, then you're adding about 7 parts per million of calcium to the pool. And if you use 10 parts per million of chlorine a week, that means your calcium level is going to go up by 7 parts per million per week. So in 10 weeks, you're going to have 70. In 15 weeks, you're going to have nearly 100 parts per million of calcium more in the pool than when you started.
Mm-hmm.
And that would be in about 4 months. So, and which is worse over a 4-month period to have 400 parts per million of TDS or 100 parts per million of calcium.
I think that we'll let the listeners decide that one for themselves. Here's another one that I hear a lot. We know this isn't true, but I don't know if it's the salespeople in the stores telling them this, but all acids are pretty much the same. Muriatic acid, sodium bisulfate, the dry acid, and acid magic. You can use any of these. It's not going to be a problem. If you can't find muriatic acid, go ahead and switch to sodium bisulfate and use that in your pool. That's probably not entirely true because they're all different kinds of acids, right?
Yes, they are different kinds of acids, so they're not all equal. So the pH alkalinity adjustment tool lists dry acid and muriatic acid. It does not list sulfuric acid, but and those would be the 3 common ones, would be liquid acid, dry acid, and sulfuric acid. muriatic is hydrochloric. But in any case, one of the problems with using dry acid is the fact that it is a sulfate, and adding sulfate to the water can eventually cause a problem. And when you get above about 300 or so parts per million of sulfate in the water, you can start to get calcium sulfate scaling. And the scale is pretty difficult to remove. It's a little more difficult than calcium carbonate to remove from the pool. So, and the other sources of sulfate in the pool are monoper sulfate. So when you add oxidizer to the pool, you add sulfate. When you add dry acid to the pool, you add sulfate. And if those things build up, you start to get calcium sulfate scale, and that doesn't show up on the saturation index that we use. So you can have scale in the pool even when you think you have a good LSI. You can have scale in the pool, and it's because of the sulfate. And we don't test for sulfates. There are some companies that have sulfate test kits, but so it is possible to have a problem with that. Sulfate also can be used by algae as a food source. So even though we may be getting rid of phosphate in the water, sulfate might be something that the algae can use in place of phosphate. So it's not all the same. You know, the goal is to get hydrogen ions into the pool, and when you add HCl, you add hydrogen ion and chloride ion. When you add dry acid to the pool, you're adding sulfate and hydrogen ions. When you add sulfuric acid, same thing, except that it's much stronger. There's more of it. So there is that. The other problem with dry acid, and I'm not picking on it, I'm just telling you the reality. Dry acid is called deliquescent. And what that means is that it can absorb water from the air and make a liquid out of itself. And you may have noticed that when you take dry acid, if you spill some on the deck, when you come back, it's wet or it's a puddle. And it's absorbed some humidity, some water from the humidity, and made itself into a liquid. And that process is called deliquescence. But so there is a problem with using dry acid, in that you need to make sure you keep the containers very tightly closed so that no air gets in there with humidity in it.
Yeah, and also I think with the dry acid, correct me if I'm wrong, if the alkalinity is higher, let's say 120, 140, you're going to need more of that product to lower the pH than if you were adding muriatic acid to a pool with a high pH, with a high alkalinity.
Well, yes, you probably would. And again, the amounts of acid that you might need are listed on those calculations are very complex, by the way. And the pH alkalinity adjustment tool does over 111 different calculations to try to figure out the amounts of acid and that you need to adjust pH and alkalinity.
Yeah, because I noticed on the bucket of, if you actually read the label of the chemical product, which people don't usually do,
Right.
But I've read the whole thing on a bucket of the dry acid, and one of the things it does mention is that if the alkalinity is really high, use an I think one of them says use muriatic acid to lower that first, and then you can use the dry acid to maintain the pH, because I think you have to use more of that product, and they don't want people using a ton of that in their pool for some of the reasons you mentioned. I think would be counter to that. And I would say maybe the acid magic would be more of a direct switch to muriatic acid, but it's like 3 times the price of a bottle of muriatic acid, the acid magic product.
It's got some additives and enhancements in it, and but you do, because they put that stuff in there, pound for pound, or volume for volume, you're going to need more of it, and it's already more expensive. So
yeah,
whether or not you want to use it is a personal decision.
Yeah.
There was some information out there about not using dry acid with a chlorine generator. I explored that and researched that and talked about it with Richard Falk. It is not a problem to use dry acid with a chlorine generator. The directions from, I think it's Pentair, says not to use dry acid with a chlorine generator. And we looked up the original document that they saw, and there was a mistake in the document. And so it's just been passed on forever.
Yeah.
But it is okay to use it. But the real warning for me is the calcium sulfate scale is a problem in this industry that we don't address. And the more that you increase the sulfate level, the more you have the potential to get scale. And it's not something that we test for or use as part of the saturation index. And so you can get scale despite having a good LSI.
Mm-hmm. So that's a word of caution for those that are switching to the dry acid product, that keep an eye on that, because that's something that no one really talks about except you. You're the one that first time I heard it too is right here. So that's new information, and I think it's vital information that probably should be disclosed somewhere else too, maybe on a labeling or something. But to get a manufacturer to put that on there is probably not going to happen anytime soon. And if you're looking for other podcasts that I've recorded, you can find those on my website, swimmingpoollearning.com. Just click on the podcast icon, and there'll be a drop-down menu of over 1,600 podcasts there for you to listen to. And if you're interested in the coaching program that I offer, you can learn more at poolguycoaching.com. And thanks for listening to this podcast. Have a great rest of your week, and God bless. This episode is brought to you by HASA, providing products that deliver clean, healthy water for every aspect of everyday life. The bottom feeder battery-powered vacuum system, portable, powerful, and only weighs 12 pounds. And Skimmer. Get Skimmer, America's #1 pool service software. Podcast listeners can try Skimmer for free at getskimmer.com/poolguy.